Hello students, welcome to CMIS online classes, and this video is for class 6, chapter number 11, light, shadow and reflection. So this is the third part of the chapter. So in our first two parts, we talked about luminous, non-luminous objects, then formation of shadows, and in this chapter we will be talking about properties of light, then pinhole camera and the difference between image and light, or sorry, image and shadow. Okay, so let's start with properties of light. So as we all know that light travels in straight lines. That means it is one of its property. The second property, it travels faster than sound. And light has also one more property, that means it reflects, okay, by which we can see an objects. So we have an experiment here. Okay, so I think we have already discussed about this experiment, but also we will revise. So here we are going to take three boards, okay, three cardboards, and a hole is made in each cardboard, and that hole must be at the same place. So if we place three boards, board A, board B and board C, and at one end a candle is lit and the other end we will see through the holes. So what we will see is that we can see the flame of the candle, but if any of the board is misplaced, that means if we move board B or board A or board C, okay, what will happen? We can't see the flame of the candle, and that is because the board that we have moved act as an opaque object, that means opaque material, and it stops the light, and this proves that light travels in a straight lines. Okay, so then we will talk about pinhole camera. What do you mean by pinhole camera? So pinhole camera is a simple camera which will prove that light travels in a straight line. A pinhole camera is the simplest form of a camera. It makes use of a single tiny openings to focus light into a single point, and it doesn't have any, what you can say, electric or the mirrors. There is no mirrors and there is no external device. There is no lens in this camera. A pinhole camera is the simplest kind of camera. It doesn't have lens. It just makes use of tiny openings, that is called pinhole, to focus all light rays within the smallest possible area to obtain an image as clearly as possible. The simplest image formed using a pinhole camera is always inverted. Inverted means opposite. Okay, that means if you see a thing from a pinhole camera, then if the head is on the top, you will see the head at the bottom. Okay, so that is inverted. And a best example of pinhole camera is that of a sunlight. Okay, in a dense forest, the light rays will come or will fall to the holes or the gaps of the leaves, and by which the shadow is formed or the light is focused on the ground. So that is a good example of pinhole camera, the rays of the sun through the trees. Okay, now let's talk about image formed by pinhole camera. As already discussed that the image formed by pinhole camera is inverted, as we can see here. Okay, that means the tree, we see the tree inverted. That means the grass or the leaves are on the ground, and the trunk or the base is on the upper end. So this is a simple image formation of a pinhole camera. So what are the uses of a pinhole camera? It must have some uses also. Okay, so image formed by the pinhole camera may be projected on a translucent screen. That means translucent screen means which allow light to pass, which allow little light to pass through them for a real-time viewing or safe observation of the solar eclipse. That means if there is a eclipse, what we can say that grahan, okay, and it is said that it's not good to see the eclipse with your naked eye, okay, or with your eyes, because it can damage your eye. So we can see through a translucent screen. You can use the blotting paper or the butter paper, okay, or even you can use that frosted glass also. Okay, so to view the eclipse, pinhole camera is used. Another example, pinhole photography, is to capture the movement of the sun over a long period of time. That means movement of the sun can be best viewed by pinhole camera. Third one, pinhole camera are sometimes used for surveillance also, because they are difficult to detect. Surveillance means for detective purposes, okay, where if no one is looking, then we can place a pinhole camera there and it can't be detected. Why it can't be detected? Because it is a simple camera. It doesn't have any gadgets or it doesn't have any lens. Okay, so it is very difficult to detect. So this was all about uses of pinhole camera. So now we will talk about shadow. As about shadow we have discussed earlier also, but let's be more precise. Okay, so what is shadow and what are the three things required to form a shadow? Okay, so as we all know, shadow is the dark area formed by an object when an opaque material blocks the light, okay, or the source of light, as we can see here in the picture. Okay, so there is a shadow of a bear, and the toy of a bear act as an opaque object, and there is a light source from the torch light, and if the torch is switched on, okay, that opaque material, that means the toy, it acts as a opaque material and it blocks the light, and a shadow is formed on the screen. Okay, so to form a shadow we need an opaque object. Sometimes shadow can also form in a translucent object also. Okay, so what are the things that things required to form a shadow? So we require three things to observe a shadow. First of all, a source of light. To form a shadow we need a source of light. Okay, for this if there is no source of light, no shadow will be formed. Take an example of a dark night. Okay, if the room is very dark, then there is no formation of shadow. Why so? Because there is no source of light. Okay, then we have an opaque object to obstruct the path of light. That means to stop the ray of light we need a opaque object. An opaque object can be anything. It can be wall, it can be the hood, or the material, or even our body also act as a opaque object. Then at last, a screen on which the shadow can be seen. We need a screen or a place where shadow can be seen. As for example, if there is light, okay, but the wall is of black color, okay, the shadow is not seen. That means it must not be black, it must be of light colored. Okay, so we need a screen. So we need three things to form a shadow: screen, opaque object, and source of light. Okay. Now let's move towards difference between image and shadow. What is the difference between shadow and image? So we talked about shadow, and we will be differentiating it with the image. So shadow, they do not have color. They are only black or gray. That means if the shadow of a colored object is not colored, the shadow always will appear in a dark or gray or black in color. Okay. Second, shadow shows only the outline of the object. That means the whole body structure is not seen. Only the outline of a object is seen. Third, it is found when light is blocked. So as we all know, shadow is found when light is blocked by an opaque material. Shadow doesn't displace lateral inversion of an object. That means lateral inversion means if we stand near the mirror, okay, what we will see? The object left hand is that image right hand. Okay, and object right hand will be the image left hand. So in shadow, that is not seen. Whereas in image is the same color as the object. That means if I am wearing a red cloth, okay, then the image which will be formed is also of the same color. Exact replica of the object and gives all the detail. That means if in the chest, if there is a stripe of white stripe, and the white stripe is also seen. That means not only the outline, the exact image is seen of the object. Then it is formed due to reflection of light, not blocking of the light. Image is formed due to reflection of the light. Then we have image displays lateral inversion. That means, as I told, that if a person is standing on a mirror, the image that is formed will be lateral inversion. His left hand or left leg will act as the image right hand or right leg. Similarly, the right leg and right hand of the object will appear left leg and left hand of that image. Okay, so that what it is called lateral inversion. Then we will talk about pinhole camera. What do you mean by pinhole camera? So pinhole camera is a simple camera which will prove that light travels in a straight line. A pinhole camera is the simplest form of a camera. It makes use of a single tiny openings to focus light into a single point. And it doesn't have any, what you can say, electric or the mirrors. There is no mirrors and there is no external device. There is no lens in this camera. A pinhole camera is the simplest kind of camera. It doesn't have lens. It just makes use of tiny openings. That is called pinhole, to focus all light rays within the smallest possible area to obtain an image as clearly as possible. The simplest image formed using a pinhole camera is always inverted. Inverted means opposite. Okay, that means and let's move to laws of reflection. In laws of reflection, we have incident ray. The light rays falling on any surface is called the incident ray. That means the source of light. Then reflected ray. Reflected rays means those light which is reflected. Okay. Then we have a normal ray. The line perpendicular to the reflecting surface is called the normal ray. Then we have angle of incidence. The angle which forms between the normal ray and the incident ray is called angle of incidence. Similarly, the angle formed between the normal ray and the angle of reflection is called angle of reflection. We will see a figure here. So as we all talked about the incident ray, means the light is reflected on a plane mirror, and that is called incident ray. And if it is reflected, it is called reflected ray. Okay, and the line perpendicular to the mirror is called normal ray. And angle of incidence is angle between incident ray and the normal ray, and angle of reflection is angle between the normal ray and the reflected ray, as we can see in the figure. Then we have types of mirror. So what are the different types of mirror? Mostly we find two types of mirror: plane mirror and spherical mirror. Okay, spherical mirror is also again divided into convex mirror and concave mirror. Okay, so normally plane mirror is mostly used. Okay, and in this chapter we will only discuss about plane mirror, but we will come to know what do we mean by convex mirror and concave mirror. So let's see here. There is a plane mirror here. An object, if it is in front, it is called plane mirror. Concave mirror, when the object is inside the curve mirror, it is called concave mirror. And at the exterior of the curve mirror, we can say it is a convex mirror. Okay, so types of mirror. So image formed from a plane mirror are reflected image in the normal proportion, but reversed from left to right. Okay, they are mostly widely used mirror. That means plane mirror are mostly used. Okay, they are common. Okay, we can see at the barber shop, or we can see at our home, or at the malls, or in shopping complexes, at extra. And those image are reversed. Reverse means left to right. Okay, that means what you can say, as already discussed, that if you stand in a plane mirror, your left portion will act as a right part, and your right portion will act as a left part in that image. Okay, so plane mirrors are flat and make virtual images. The image is virtual because the light rays do not come from the image, they only appear to. Means whatever the thing is, that it will appear. Okay, so what are the uses of mirrors? Simply, mirrors are mostly used at our homes. Okay, to see different types of things, like in barber shop. Okay, to see the cutting of the hair. Okay, or to see the face, or to while washing the face. Okay, plane mirrors are used. Even it is also used in periscope to see the objects which are above us. Okay, as for example in submarines. Then mirrors are used in car headlights. Okay, or in different vehicles also, to see an object which is rear or which is at the front.